Problem 61. Here we have this body which contains of a disk and also a rod which they are combined together. And this body is sitting on a smooth plane. The mass of the rod is half a m and mass of this disk is half a m as well. And the m is given, m is equal to 1.2 kilogram, the total mass. And we know all the geometry. We are applying 6 Newton at this corner perpendicular to the rod. And the question is, what's going to be the angular acceleration of this body, and also what's going to be the acceleration of the centroid of this body. To make it a little bit more visible, I'm going to draw it in 2D. And let's say we are looking at from the top. The centroid of this rod is going to be here, and the centroid of the disk is going to be here. And of course, the centroid of the whole system is going to be somewhere between these two, right at the middle of them, right? The distance from here to here is 250 millimeter, and the distance from here to here is going to be 250 plus 100, 350. So the distance between these two is going to be half of that, 175. From here to here is 175 millimeter. We are applying force P at this corner. So this is going to be the centroid. And the equation is quite simple, right? If I say this is my x direction and this is my y direction, then based on Newton equation, sum of the forces in the x direction is equal to mass times acceleration of the centroid in the x direction, but there is no force in the x direction. So acceleration of the centroid in the x direction is going to be equal to 0. Sum of the forces in the y direction is equal to mass times acceleration in the y direction, acceleration of the centroid. And the only force we have here is P, which is given 6 Newton. So if we divide 6 Newton to the total mass, 1.2, we are going to find acceleration in the y direction, which is going to be 5 meters per second squared. So that was simple. To find alpha, let's say, I'm going to say this is the positive direction for alpha. Sum of the moments about the centroid is going to be equal to Ig times alpha. And the moment about the centroid is going to be force P times this distance, which is going to be 250 plus 175 millimeter, right? Which is quite simple. So alpha is going to be that moment divided by I of the whole body about G. But the question is, what is Ig? Actually, the point of this problem is just calculating this Ig. We have a composite body here. We can find the mass moment of inertia of this rod about the centroid of it, then use parallel axis theorem to find the mass moment of inertia of this rod about point G, and do the same thing for the circle. For the disk, we know what is the mass moment of inertia about the center of it, but we need to add mass times distance squared to find the mass moment of it about G. So Ig is going to be equal to mass moment of inertia of a disk about the center of it is going to be 1 over 12 times mass of it, which is m divided by 2 here, times length squared, and the length is 0.5 meter. Then we need to add mass times distance squared to find the mass moment of inertia of the rod about G. Mass is equal to m divided by 2, and the distance is 0.175 meter squared. For the disk, the mass moment of inertia about the center of it is 1/2 of the mass of it times the radius of it squared. And using parallel axis theorem to move it to this point, we need to add mass, which is m divided by 2 for this, for the disk times distance squared, which is 0.175 squared. So we can calculate IG by putting m is equal to 1.2 here, and IG is going to be equal to 0.0522 kilogram meter squared. Simply by putting IG here and m is equal to force times the distance. Force is 6 times, let's call this 1 from 1, 6 times 0.25 plus 0.175 meter. The moment of P by G is going to be equal to IG, which is 0.0522 times alpha. From here we can find alpha. Alpha is going to be equal to 48.8 radians per second square in this direction. So it is positive in this direction, it means it is clockwise. So that's going to be alpha.